Salinity is really the driving force that makes the estuary an estuary. If we don't have the salinity in the right ranges, we're going to lose seagrass. It's the basis of the estuary nursery. It's the food source for manatees. It's also a big driver in oyster reefs. This area is very ecotourism driven. We've had some issues with a really bad red tide in 2018. It killed everything from whale sharks to huge Goliath grouper washing up on the beach. Having this data is going to be really helpful to see where we were, see where we're going, and to try to predict, how to make things better going forward.
Hi, I'm Stephanie Andrews.
Climate scientist,
ocean adventurer,
and systems specialist at NexSens. Today, the Caloosahatchee River is a predominant source of agricultural water supply in the region, and it also supplies residents in southeastern Glades County with fresh water. It meets the Gulf at San Carlos Bay and has major impacts on ecosystems up and down Florida's southwest coast. The Caloosahatchee's environmental transformation began over a century ago. It's been connected to Lake Okeechobee, and in the 1930s, the US Army Corps of Engineers took over and began to install flood control structures. But these introduced new contaminants to the waterway. Scientists now think that agricultural and urban runoff from areas around the lake, coupled with growing suburban land uses in the watershed and by the coast, are the root cause of deteriorating water quality in the Caloosahatchee Estuary. The Sanibel-Captiva Conservation Foundation was founded in 1967 and is tasked with monitoring the river and estuary, managing projects ranging from wildlife management and habitat restoration to environmental education and water quality monitoring. AJ Martignette oversees the SCCF's River, Estuary and Coastal Observing Network, known as RECON, which collects water quality data via a series of 9 environmental monitoring stations dotted throughout the Caloosahatchee, from the river to the Gulf.
So we're in a heavily man-made, manipulated system in that we have Lake Okeechobee in the center of the state, which is controlled for both agriculture and flood control by the Army Corps of Engineers. That has caused some problems with getting water where it needs to be at the right time. And in order to know exactly what was going on at any given time, we decided we needed a real-time system. RECON is really unique at an organization of our size. It costs a lot to buy the sensors and to operate them. And we're really lucky that we have a lot of donors who specifically have funded both RECON when we started in 2007 and when we needed to replace the sensors and data loggers.
Piling-mounted systems can be found deployed throughout the Sanibel area. Each is equipped with a NexSens X-Series sub-data logger. Now these data loggers are special. They can tolerate submersion for long periods of time, and they continue collecting data even when underwater, ready to transmit data once the water recedes.
I wanted them because of the connectors that are used on them. They're more robust should the sensor actually go underwater. We have had, both due to hurricane storm surges and a piling being knocked over by boats, the data loggers go underwater and they all survived.
The system configuration depends on the deployment location, but they commonly include a weather station, Seabird Scientific Hydrocat CTD, and Eco Triplet Fluorometer.
We have 2 sensors in the freshwater part of the river. We put those there to deal with cyanobacteria outbreaks and to get some data on that. We have a couple sensors in the upper estuary in the river. We have one at the mouth of the river and one in the refuge here down in the estuary. And finally, we have one right off Fort Myers Beach, basically in the Gulf. The biggest thing that we're interested in is salinity, because that's the one water quality parameter we can kind of control. We have multiple sensor suites. The Hydrocat does your standard CTD measurements of temperature, dissolved oxygen, conductivity, and depth. And then the triplets, we have FDOM, or basically how brown the water is, chlorophyll, or how green or how much plant life's in the water, and then turbidity, or how stirred up the water is. We have that of all of our sites, and a few of our other sites in the river have a phycocyanin, which is a blue-green algae pigment sensor, and we have a nutrient sensor at one of our sites as well.
Collected data is transmitted to the cloud via the X-Series data logger, where it can be easily shared with other researchers. Data from these systems also contributes to the publicly available SCCF online site map, helping inform any interested members of the public of environmental conditions. Eric Milbrandt is Marine Laboratory Director at SCCF, and he's part of the scientific team using the RECON data for research.
The data itself is very useful in machine learning applications. Several departments at the University of South Florida, University of Florida, University of Central Florida are all using the data to build these either hydrodynamic models or in some cases just very simplistic empirical models for decision making. Well, let's just talk about harmful algal blooms for a second. These are phenomena that happen in coastal areas where you have enriched nitrogen and phosphorus and high light environment. It produces phytoplankton and they can become a nuisance, or in some cases if they produce toxins they become problematic for people. One of the things that we use to predict where the blooms are ocean transport models, three-dimensional hydrodynamic models. Those models need hourly salinity and temperature because the estuarine systems are very dynamic. And so they need the data not only over a 10-year period to calibrate the models, but also on a predictive basis, they need it to start a 2-week forecast. You need the data from the last 2 weeks fed in to help us understand harmful algal blooms.
Florida's location puts it directly in the path of storms that form in Hurricane Alley. That's the warm patch of water that stretches from the west coast of Africa to the Caribbean and the east coast of the United States. Data from the RECON systems has also been valuable during hurricane season.
We made the decision years ago that we weren't going to pull sensors in during hurricanes. One of the cool things with WQ Data Live is I can change the sampling schedule remotely. So we normally measure water quality every hour, but when the hurricanes were coming through, we bumped that up to 15 minutes. We've lost some weather stations, actually all of them during Hurricane Ian, but we were able to get some good wind data that we've actually shared with people.
And it's extremely useful in showing, especially like changes in water levels. Very important for those of us that live on an island that's very low-lying. We want to use the real-time data to inform emergency managers, but also in hindsight to be able to explain what happened.
Environmental monitoring is just one aspect of the SCCF's work, yet it underpins their science, education, and advocacy. By sharing real-time data with scientists, policymakers, and the local community, they're helping build a brighter, more resilient future for Southwest Florida. Visit NexSens.com for more information. NexSens, better data. It's never been easier.